Hello, my name is Magnus Petersen, and this is my tutorial number 3B on TensorFlow. It was actually recorded after tutorial number 16 on reinforcement learning, but I thought it would be better to call it 3B because it is more related to tutorial number 3 on PrettyTensor. And this tutorial is about the Layers API, which is a so-called builder API used for constructing neural networks in TensorFlow. And what you see here is from tutorial number 2. And this was before we used these builder APIs. And this means that we would have to allocate variables and set up a lot of things in TensorFlow. And to do that, we made these helper functions like this one for creating a new convolutional layer. And here is a helper function for flattening the output of a convolutional layer so it can be input to a fully connected layer and looks like this. And here we have a helper function for creating a fully connected layer. And the idea with a builder API is that it provides all these helper functions for us. About 9 months ago, I wrote this issue on GitHub where I asked the TensorFlow developers to please consolidate the builder APIs because they already had several and there are actually now more than I have written here. And this one on the top is called tf.contrib.layers. So this was originally an experimental add-on to TensorFlow. And they have now moved some of the features, but unfortunately not all of them, into tf.layers. So it is supposed to be an integrated part of TensorFlow from here on after. And what I have used in most of the tutorials is this one called PrettyTensor. And this is what tutorial number 3 is about. And I used PrettyTensor because at that time it was the most polished and well documented, even though the documentation was actually not very good and it hasn't really improved since then. And now they also have another popular one called Keras, and so on. Now, PrettyTensor is only developed by one person inside of Google. And imagine if that person decides to leave Google or work on something else or whatever, and he will then stop developing PrettyTensor. I haven't really been able to get a clear answer from the Google developers which builder API do they want to support in the future. They set this one tf.layers, but as you will see in this tutorial, it's not complete yet, even though it's fairly simple and it should be easy to do. I actually think this is a big problem because the builder API is what most people are going to use when they are doing things in TensorFlow, and it should have been locked down a long time ago. And my suggestion in this post was to take the best features of the different APIs, consolidate them or mix them together, and make a good documentation so people could rely on it in the future. The way it has been done now is very confusing for the community, and it has created a lot of trouble for everybody who wants to use TensorFlow. And without going into a long rant, I think this is a management problem. I think the team leader of TensorFlow should have said to his engineers, no, you cannot make 5 different builder APIs. We need one. It needs to be good. It needs to be polished, well documented. But I can't convince them, so this is what we are stuck with. So let's take a look at the Layers API, which was added to TensorFlow Core in version 1.1. And let's see how it is different from PrettyTensor that we have been using so far. There are pros and cons of both. So what we want to implement is this convolutional neural network, which is the same that we did in tutorial number 2 and number 3 on PrettyTensor. And we have an input image from the MNIST dataset, and it is 28 by 28 pixels, and we send it through the first convolutional layer, where the filters or the kernels are 5 by 5 pixels, and we have 16 of those, and this outputs 16 channels. And to see how this convolution works, you need to watch tutorial number 2. And we also have what is called a max pooling layer, which effectively just downsamples the output of the convolutional layer so that the images are now 14 by 14 pixels. And because we had 16 of these convolutional filters, we now have 16 channels. And then we have convolutional layer number 2. And this is a little more complicated because it has 16 input channels. But again, watch tutorial number 2 on how to do this. And this then outputs 36 channels where it has also been max pooled again. So it's downsampled again to now 7 by 7 pixels. Then we have to flatten this and input it to a fully connected layer with 128 features or neurons or units or whatever you like to call it. And then we have another fully connected layer, one for each of the possible classes of the input image. And we then process this with so-called Softmax, which means that all of these numbers are between 0 and 1 and the sum to 1. And then we take the index of the largest number, in this case it's 7, and we say, oh, the input image here is class 7. And then we want to train these weights and bias values in the fully connected layers and in the convolutional layers, so the whole network becomes better at classifying the input images correctly. So we will see below how to implement this in PrettyTensor and in the Layers API. So here are the imports, and the only difference from tutorial number 3 on PrettyTensor is that we no longer have to import PrettyTensor because we don't use it. The Layers API is a part of TensorFlow, so it should work for everybody. I have had some reports and some complaints that PrettyTensor is either difficult to install or they can't install it at all, but you won't have that problem with the Layers API. And here we load the MNIST data, and this is just the same as tutorial number 3. And we have the dimensions for the data. Again, this is just the same, and we have a helper function for plotting images, and we can plot a few of them and see that this looks correct. And then we get to the point where we want to construct the TensorFlow graph. So remember that the way TensorFlow works is that we are building this computational graph, which has some input, it has some mathematical processing, and it has some output. It can also have some logging functionality, but we don't use that here. And then whenever we wanted to actually compute something or calculate something, we have to feed some image data into the graph and then ask it to compute the output, and then we can retrieve that. And the idea of doing this is that if you're using a lot of data, it might even be gigabytes of data, then this is a lot faster than doing it in, for example, NumPy, or certainly in Python directly. And you can also use GPUs to greatly speed up this. So first we need the placeholder variables, and these are the inputs. And the thing about a placeholder variable is that if we don't provide this data and it is needed for doing the TensorFlow computation, then it will raise an exception. So we are reminded to always provide this data. And we have X here, which is a tensor or a multidimensional array. And this none here in the shape means that it can have an arbitrary number of images. And each of these images is then a vector or an array of this size here. But the convolutional layers assume that we are inputting a batch of images that have a height and a width and a number of channels. And in this case, the height and the width is the same, 28 pixels. So in order to do that, we need to reshape the data that we are inputting. And we do that with this operation here. We also need the true class of each image in the batch. And these are one hot encoded, which means that for each image, we have an array or vector with 10 elements, and they are all 0 except for the one with the true class, which has a 1 in it. And what we want to do is we want to train the neural network so that it outputs the correct class for as many images as possible in the test set. So now we get to the point where we actually implement the neural network, and this is done with PrettyTensor just so you can easily compare it to how we will do it with the Layers API. And it is wrapped in this if-false block so that it will not actually execute. But in PrettyTensor, we first had to wrap the input that we want to process in the neural network. So we do that here. And this creates a new object which has functions that will create the layers in the neural network. So we call xpretty.com2d. This creates a convolutional layer. And then we have a dot again because we are just chaining these function calls. It keeps returning this PrettyTensor object, and this means we can just chain all these calls. So first convolutional layer, the max pooling, second convolutional layer, max pooling again. We flatten the layer so we can input to a fully connected layer, and finally we have the Softmax classifier. So this here corresponds to the flowchart that we had in the beginning here. In my opinion, this is very simple and elegant, and there are also some extra features, like we can set a scope here so that all of these function calls here have these parameters that we set here. And these are some features that would be nice to have in the Layers API. As you will see below, we have to write a lot more text to do the same thing. Another thing is that PrettyTensor gave us both the output of the neural network, which we have called ypret, and it gives us a loss function. So this is quite elegant. Now let's see how we do it using the Layers API. We can no longer chain these function calls for creating the layers in the neural network. What we do instead is that we have a reference to the last layer that we have made, so that it is very easy to experiment and add or remove layers in the network. We give this a short keyword like net, and in the beginning we just set it to the input images. Then we create the first convolutional layer here, and we set its input to be the net variable, which was just the input images that we set here. Then we give the layer a name, and we have to specify the padding for the convolution because the default setting is not what we want here. And then we have the number of convolutional filters and the size of each of these filters. So these are 5 by 5 pixels. And then we have the ReLU function as the activation function for this convolutional layer. Now, one of the advantages of this way of constructing a neural network is that it is much easier to reference different layers in the network compared to how PrettyTensor does it. Further below, we want to print the output of the first convolutional layer. So we just save a reference to this layer that we have just created up here, and it's held in the net variable, and we just save another reference. So later on, it is very easy to calculate the output of this convolutional layer. After this, we have to do the max pooling. So we just set the input to the net variable, and we want to have a window size or pool size of 2 by 2 pixels, and we want to move the window by 2 pixels every time. And again, you should watch tutorial number 2 for an explanation on how this works. And then we can add the second convolutional layer. And again, we are using the net variable as the input, and we give it this name here. And we have the same padding, and we use 36 filters, and they are each 5 by 5 pixels, and we use the ReLU activation function. Again, we want to plot the output of this convolutional layer further below, so we just save a reference to this layer in a variable like this. Once again, we want to do max pooling, and it's just done in the same way as before. And if we just look at the tensor that is now output by this second max pooling layer, we will see that it has a shape of question mark 7736. And the question mark here means that the batch size can have an arbitrary length. And each image is 7 by 7 pixels, and there are 36 channels. So if we go back and look at the flowchart, it corresponds to this data that we are outputting here. And now we want to flatten all this data so we can input it to a fully connected layer. So let's go back to the code here. And this is one of the problematic issues about the Layers API that I talked about before. This function for flattening the output of a convolutional layer so it can be input to a fully connected layer, it has been implemented in the tf.contrib.layers module, but it is not implemented in tf.layers. Why not? I don't know. But it is just little things like this that it is so incredible that even after a year, this is something it would take an engineer at most a day to do. And it's just frustrating that it's not done, because now, when they finally do deprecate tf.contrib.layers, I will have to go into this notebook and change this. And whatever code you are writing using the Layers API, you will have to do the same. Is it unprofessional? You bet. Anyway, we now have the data flattened, so the tensor has a shape of question mark, so this is the batch size. And if you multiply 7 by 7 by 36, you should hopefully get 1764. So this data in this tensor here has just been flattened to another tensor here. And we can then add the fully connected layer, which they have for some reason called a dense layer in the Layers API. And as usual, we will set the net variable as the input, and we give it this name here, and we say that we want 128 units or neurons or features, and we want to use the ReLU activation function. Then we need another dense layer or another fully connected layer, and this one must have an output for each of the possible classes. So this is 10, and otherwise it's just constructed in the same way, except for this activation function because we set it to none. And in a lot of the TensorFlow API, you will see reference to logits, and this is just the final output of the neural network before the Softmax function, which we then create here. So that ypret is an array of 10 numbers for each of the input images, and each of these numbers are between 0 and 1, and they sum to 1. And then we take the index of the highest number, and this is the predicted class. So if we go back and look at the flowchart, what we get out here is a predicted class number 7, and this array here is the output of the Softmax function, and all of these other layers are the ones that we have just constructed using the Layers API. And now we need to create a so-called loss function or a cost measure, which is comparing for each input image this output of the Softmax classifier, so the true class label. And TensorFlow can automatically do that because it uses the so-called chain rule of differentiation, so that all these layers are really just mathematical functions, and then it can calculate the gradient so that we can change all these little filters and weights and variables, so the whole network becomes a little better at classifying input images. And this can then be done thousands of times until it is good enough. So in order to do this, we need to create this loss function, and first we calculate the so-called cross entropy, and I believe this was explained either in tutorial 1 or 2, but this measures how close the output of the neural network is to the output that we actually want. So it compares the output of the neural network, which we have in this logit variable here, to the true classification, which is a one-hot encoded array that we had in a placeholder variable above. And we now have this so-called cross entropy for each of the input images in the batch, and we then just reduce it to a single scalar value by taking the mean. So what TensorFlow does is that it calculates the gradient of this loss function here with regard to all the variables in the computational graph, and then we can use an optimizer, which we have here, to move in the direction of this gradient, and if we do this thousands of times, it will gradually become better at outputting the correct class numbers for the input images. Further below, we want to plot the weights of the convolutional layers, and the problem is that these are allocated by the Layers API, so we don't know what their names are, and in order to get them, we need to know their names. So this little code here prints all the global variables in the TensorFlow graph, and we can see here that the Layers API has called the variables for the convolutional filters for kernel. So these are the ones that we want to plot. We have it for the first convolutional layer here and for the second convolutional layer here. So we just have a little helper function for getting these variables out. And these are actually just references to the variables that are stored inside the TensorFlow graph. And we will need to run the TensorFlow session in order to actually get the contents of these variables out. And we create this TensorFlow session here. We initialize all the variables. And all of this code is just the same as in tutorial number 3 on PrettyTensor. Probably also the same as tutorial number 2, because the only thing we have really changed is the construction of the neural network. So I won't go through this in detail. We have various helper functions. Here's one for doing the optimization of the neural network. And here's one for plotting example errors and for plotting the confusion matrix and for showing the performance or the accuracy on the test set. And as we can see, the classification is very bad on the test set when we haven't trained the neural network. It gets 5.8% accuracy, and that is because it just makes random guesses. After we have done one optimization iteration, it only gets a little better, but after 100 optimization iterations, it gets a lot better, and now we get 81.2 classification accuracy on the test set. And here are some examples of images that have been misclassified. For example, this is supposed to be a 9, but it has been classified as a 7. This is supposed to be a 5, but it has been classified as a 3, and so on. After 1,000 optimization iterations, we get an accuracy of 94.5%. And here we have some examples of misclassified images again. And after 10,000 optimization iterations, we now have a classification accuracy of 98.8% on the test set. And once again, we have some examples of misclassified images. Like this one is actually easy to see that it's an 8, but for some reason it has been classified as a 6. While this one is difficult. It says that it's an 8, but I don't know what this is supposed to be. So I think it's a fair mistake that the neural network has made. This one is also obviously a 6, but it has been misclassified as a 0. Anyway, we can now visualize the weights of the convolutional layers and what they are outputting. So we have a few helper functions for this, and this one here. And this is one of the images that we will input to the neural network, and this is the other. So what we see here are the kernels or the filters in the first convolutional layer, and the positive weights are red and the negative are blue. And this is the output of the first convolutional layer, and this is for the second test image. And here we have the filters or the kernels for the second convolutional layer, and this is for the first input channel, and there are actually 16 of these. And here we show it for the second channel. And when we process the output of the first convolutional layer using all these filters, we get this output here. And it appears that it has maybe learned to recognize lines. For example, a line here, and a line here. And here we have it for the second test image, which was a 0. And that's it. Personally, I prefer the PrettyTensor API because I think it's much more elegant than the Layers API. But there are certain things that are easy in the Layers API. For example, if you want to branch the neural network into several sections, or if, for example, you want to have several outputs of the neural network, then that is a lot easier to do in the Layers API. I wish that they would take some of the good features from PrettyTensor and add them to the Layers API. For example, this one here, where we could set default parameters for the layers in the neural network. Here we have set the activation function to be ReLU. And let me just show you an example of why this is a nice feature to have. Yesterday, I added support for the Layers API in my reinforcement learning tutorial. And this is the construction of the neural network using the PrettyTensor API. It is very compact and elegant, and you can easily see how the neural network is designed. And here it is using the Layers API instead, where this is just for creating a single convolutional layer in the network, and we need different parameters in each call of these functions, and it very quickly becomes a mess. So these default parameters is something that I wish they would add to the Layers API. And of course, I wish that they would focus on one builder API instead of having many different, and that they would polish it and document it properly, because it really is a big problem for the people who are going to use it, that they cannot be certain about what is the API going to look like in the future. As usual, I have made some suggestions for exercises, and especially if you're a beginner, I would encourage you to try and do some of these, and you can download the source code by clicking on the link below the video.